God's abundant grace and peace be with you, Trig analysis students. I'm glad to be able to make this practice video that you can take a look at and that we can get you well prepared for this upcoming quiz later on today. And I trust our Father will lead us and guide us and inspire us and help us as no one else can. The first question is, it says, write a verse which portrays God's passion for what is right, even for righteous triangles. So this is the first one. And the verse says, I think it says, for the Lord is righteous. I'm going to have to check that first word, but I think that's what it says. For the Lord is righteous. He loves righteousness. His countenance is upon the upright. It means his face is upon the upright. Like you. So you might say, well, I'm not upright. Well, in Christ you are. Christ has made you upright. We have to thank him very much for that. So you can see all these. Well, everything here is about him is right. As we study right triangles. Next, number 2, we're going to be doing some conversion. We're going to convert from degrees to radians. And I'm going to go ahead and just do one of each for you. This one is number 2. Let's do part C. 210, negative 210 degrees. The conversion is, the factor is pi over 180. And you might be able to remember it like this. If you're going from degrees to radians, the pi has to kind of dominate. Pi indicates radians. If you're going from radians to degrees, the 180 has to dominate, so that would be on top. That's what we're going to do next. But since we're going to radians here, the pi is on top. We can divide numerator and denominator by 10. And then you look and you see 21 or 18, you know 3 can go into both. So 3 goes into 7, 3 goes into 21, sorry. Negative 7 and 3 goes into 18 6 times. And that's as far as we can go. So this one would be negative 7 pi over 6 radians. Then we go and we take the opposite conversion now. Number 3, convert the following radian measures to degrees. Give your answers in lowest terms without using a calculator here. So let's take number 3, part C, negative 2 pi over 3. And you can tell that's in radians by the pi. Sometimes the pi might not be there because the pi is about 3 or 3.14. So if you'd multiplied it out, it'd be approximately 6 over 3, which would be approximately 2 radians here. But anyway, in converting from radians to degrees, this time the degrees dominate. They're upstairs. So that's the factor now. 180 over pi. The pi's will cancel out nicely. No more apple pie or key lime, whatever you like. And then 3 goes into 18. 3 goes into itself once. 3 goes into 18. 3 times 6 is 18, and 3 goes into 0 times. So we're left with 2 times 60, which is 120, and that's negative. All right, so that would be the answer for number 3C. Number 4. Number 4 here, we're going to do some circular motion. Now it says find the distance S moved by the second hand of a clock when it rotates through an angle of 270 degrees if the length of the second hand is 7 inches. So, quick sketch here. Oh, yeah, let me make it a little bit nicer than I would if I just did it by hand. Freehand. Over here. Over here. I'm just going to go ahead and put a circle representing our clock. It's going through 270 degrees. So, let's say it starts here in the usual position. Second hand, I'm going to give it the arrow, and it goes this way. So this is what it would do. It would go all the way around. It's 90. $180, end up right here, 270. So it doesn't start in the conventional way right here at the 0 x-axis position. We're starting it here. Alright, so again it goes this way, all the way here, so that would be 270 degrees to this point. Okay, so our angle, well, let's go ahead and do the formula first. The formula is S is equal to theta times R. So what's the S? S is the distance traveled on the circumference here. Okay, so if I could give you an indication of it, to be this distance all the way around, kind of like a runner running around a track in the Olympics, going all the way, coming to this point. So that would be the S. The R is the radius here. They tell us it's 7 inches. And this is the equation you have to remember. S equals theta R. You must remember that where theta must be in radians. Where theta must, let me put that in all caps, must be in radians. Okay, so let's work it out now. Okay, give us that theta is 270 degrees. We have to convert that to radians, and you don't have to do that, you just did it. So we have to multiply by pi over 180 to bring it to radians. Divide upstairs and downstairs by 10. You can see that 9 can go into 27, 9 goes into 18. So we have 9 goes into 27 3 times, goes into 18 twice. So this works out to be 3 pi over 2 radians. We're not looking at signs right now, we're just looking at the absolute value of the number of radians. Okay, so it's 3 pi over 2. And now S, the circumferential distance, or the distance on the circumference of the circle traveled, is equal to theta, which is 3 pi over 2, times R. R is 7 inches, and we can work that out. Alright, I'm going to work it out on my iPad right here. And I think that we wanted that answer to be intense. So I have pi times times 3, and that times 7 divided by 2. I got 32.986. So since we're rounding to the 10th place and the 9 is in the 10th place, then we have to add 1 to that 9, make it 10, and then that 1 from the 10 is added to the 2. So our answer here would be 33.0, and our unit here is in inches. So that would be the distance traveled by the tip of that second hand going around here. All right. Let's take a look at another one. The other one is similar. It's going in the other direction. And this is 4b. And it says the following. It says find the radian measure of the central angle. That's a theta now. Of a circle of radius 2 inches that intercepts an arc of 500 centimeters. So, let me give you a picture to look at. Here's our circle. And let's say we start here. We want to find the radian measure. So let's say this is our ending position. So we've traveled around. This is our distance of travel on this circumference. So this is our S. This is the central angle, theta. And the radius is 2 meters. We want to find the theta. The same formula is employed, so we have S is equal to theta times R. Again, theta is in radians. So S, they tell us, this time is 500 centimeters. So this is 500 centimeters. And 2 meters here. So I'm going to have to convert either the centimeters to meters or the meters to centimeters. So there are 100 centimeters in 1 meter. So 500 centimeters would be the same as 500 divided by 100 to be 5 meters. So for S we have 5. But theta is the one we seek. And R is 2 meters. This would be like 2 theta or 2x. So divide both sides by 2, we get 5 over 2 equals 2 theta over 2. So theta would be 2.5 radians. All right. And as our time ticks away, let me just maybe skip and do one with you back here. Let's say if we have cosine of theta, this is 1 towards, well, I didn't give you this one, this is just an extra one, equals 0.5, and I say find theta, you'd have to say theta is equal to cosine to the -1 of 0.5. All right, God bless you. I'll see you soon.